Hello everyone, my name is Shiyu, and today I'll be giving a lightning talk on techniques for addressing UDF incompatibilities between Spark and Gluten and Velox. So many companies are productionizing Gluten and Velox to speed up their Spark cluster execution time. And one of the challenges is that whilst Velox has mostly have UDF support parity with Spark, the Spark versions are written in Java, obviously, or Scala, and the Velox versions are written in C++, so there are different implementations. And sometimes, due to subtle differences in the implementation, it could lead to result mismatch. And when there's a case of result mismatch, it could lead to, due to UDFs, it could lead to further downstream result mismatches, such as joining on two columns not working correctly due to the string payload being different, or just that if the results are different, then you don't know if for a particular Spark task, whether you can proceed to replace the default Spark runtime with Gluten and Velox. So, so this is kind of a blocker for productionization. And today I'll go over some techniques for tackling this category of issues. So just some examples of UDF incompatibility. So some of the most commonly used UDFs are get.json object, regex extract, and the date format. So I think anyone who has been around large-scale ETL jobs will have seen these UDFs in the wild. And on this slide, I just list how, under the hood, the Spark and Velox version uses different, let's say, JSON or regex engines or libraries, and which could introduce complications that result in result mismatch. So so next, we're just going to get JSON object. And I'll just give a quick example of how this UDF works for those who don't know. So say you have a JSON text, and you can give it like a path, and it will return basically a substring piece that's part of the original JSON. That's the UDF. And so technique number one that I'll present is to simply port the Spark UDF logic to Velox in C++. So for example, the get.json object implementation in Spark, the way it's implemented is it uses the JSON library for the parsing and scanning of the JSON input text. And then it uses, and then on top of that, it implements a JSON path query evaluation logic above the JSON scanner. So if we were to, and the current Velox's implementation of get.json object, as far as I'm aware, do have quite some number, or at least a few edge cases where the results don't match. For example, when it comes to handling of illegal characters in the JSON, badly formed JSON, like invalid JSON, or even the escaping or not escaping of special characters. So one potential way to solve this issue would be that we would basically, we could take hypothetically an open source C++ JSON library and augment or tweak its scanner piece so that it behaves identically with JSON or as close as possible. Specifically, when it comes to illegal character tolerance, for example, I think \n, the new line character, as a literal is not legal in JSON. That's just one example. And also and also I think we could also make the scanner. So when it comes to scanning JSON text, there's the full parse strategy, which parses the whole JSON. And then there's also the strategy of just parsing the JSON as you go on demand. And with the on-demand mode, if you have a badly formed JSON, that's, let's say, prematurely truncated, if you only need to scan the first part of it, and you do that on demand, then whereas a full parsing JSON scanner will blow up and say the JSON is badly formed, if you have an on-demand scanner, then it will be able to tolerate that input. So basically, a part would involve a JSON scanner at the fundamental level that behaves closely to json. And then we could also, on top of that, we would implement a one-to-one part of Spark's Scala implementation of the JSON path evaluation logic. And if we do this, we can achieve basically better UDF comparity to the point where within, let's say you're in a big company, you could almost get it to 100% fully identical to the Spark's Scala implementation. So that's one way. And then the other two UDFs I mentioned, regex extract and date format, these are also widely used. So the reason, again, these are hard to get matching with Velox 100% is because with most of these UDFs, it comes down to using some Java or C++ library to do the heavy lifting of the core part of the UDF logic. So for example, for regex extract, Spark uses Java util regex, and for formatting date, it uses the datetime formatter. And the issue is in the C++ world, there simply just isn't an equivalent datetime formatting library or regex engine that behaves identically as the jar libraries in Java. So basically, one way is, as the first technique mentioned, you could do a full part of the logic, but that probably would be which is what this slide mentioned. So is porting a solution? I think many people might agree that it's too monumental a task to port Java util regex basically to something that's entirely written in C++. So in this case, one technique we can use is basically, because if you're running Velox with Gluten on Spark, you probably are inside of a JVM environment. For example, I believe Velox is implemented through JNI. And in that case, you have a JVM runtime already available to you, or you're running inside of one. So one technique we can use is to have the Gluten layer basically pass in a JVM reference pointer. And then once you have that, you can basically call Java libraries by writing a piece of C++ code like below. That comes from just an LLM generated code. But if you call that, then that will allow you to call a Java method from inside of Velox in C++, and it will get you basically the identical regular expression engine behavior that you'd get in Java land. So that's the second technique we can use. And yeah, thank you. I think that's the end of the lightning talk. And any questions, I'll take them. Sorry.
What about performance impact of this? Any concerns around that?
So yeah, basically, I think these two techniques would be for cases where it's critical to fix, but there are no other alternatives. So I believe if you call a Java function from Velox, it would still be faster than I think what was mentioned earlier today, which is basically fallback to Spark because there's a UDF you cannot handle, because that would involve a round trip of column to row, row to column conversion. So I think this overall would still be better performant than the alternatives available. Unless, of course, one more alternative would be for you to, for some customer to accept that result mismatch is tolerated and it's okay. You don't have to match results 100%. But I think in the context of any systematic productionization rollout, normally there's a piece of the rollout logic that basically compares the result and makes sure they're identical. And that comparison logic is usually fairly mechanical. So, which means it always comes down to probably leaning on the side of achieving result fully matching. Yeah.
Okay, thanks.